niche thing to talk about pressurisation in high-rise buildings, but it's a very critical part of the building, because unless you get it right and it's commissioned, you can't hand the building over. And I'm going to talk a little bit about the Building Safety Act and how it's changed the way that we will work in the future. But it's not just for pressurisation as an option. I think this is something as a whole smoke industry we should be looking at, and the people in this room should be challenging our industry to make sure that you're getting the right information when you start looking at a smoke clearance or a pressurisation system in a high-rise building. So, Building Safety Act. It's taken a long time to come out. There's been lots of talk about it. It is slowly starting to be embedded into our industry, particularly from a design element, and I also think from a development and architectural point of view, but we've got a long way to go before it's embedded into actually the installation of the building, also in the commissioning and the maintenance of that building as well. We've made a good start, but there's an awful long way to go, and there's a lot of education that still needs to be done. The whole point of the Building Safety Act is to help to change the mindset of the industry. We need to change the way that we work. And if we don't change, we're going to continue to have a situation where we spend most of our time not doing design and build work, but build and design work, where we end up going to site, and actually what you see on site is very different to actually what you've designed in the first place. We need to change that mindset, and I think we can show you some ways that we can start to do that. I want to highlight a few things. There's been a lot of talk about this, and I may appreciate some of you have heard all this before, but there's some real key elements that I want to just talk about. Obviously now, we're talking people understanding the difference between a higher risk building and a tall building. You're looking at anything above 18 metres as a higher risk building, and lots of different categories. But a tall building, we would say, is something over 50, 60 metres. And we'll show you how there are different challenges for designing that compared to a standard smaller building. We also, coming across this a lot, making sure you've got all the information at Gateway 2 before, in theory, it goes to planning. This sounds great, but what information do you get? And do the people that you've got that information from understand actually what they've given you and how it impacts your building? The idea of this is to be able to give the marketplace to show your competency in what you're doing. And it's not just about giving information, but how the design works. So when you're speaking to somebody, you have confidence in what they're doing for you from a design element. As an industry, and when I say an industry, I mean the smoke control industry, we've quite liked this in our marketplace for two reasons. One of it happens because some of the building regs use words like reasonable and suitable, which don't actually mean anything, so it's very difficult to actually measure it. But also, we've liked it because we've liked to come to everybody and say, don't worry about it, we're the experts, leave it to us to be able to do it for you. The Building Safety Act has changed that, because you, as a responsible person, must be able to understand what that design is. And the whole point of doing this is to be able to show you that somebody is competent in what they are doing. The idea is we should be moving that arrow to the left as far as possible and get rid of all these little areas at the moment which we have. So what does competency mean? And it's very difficult from a fire engineering perspective, from a smoke design point of view, because there isn't such a thing as a smoke engineer. You have a fire engineer who will be able to do the strategy for you, but often then the actual design of the smoke vent goes down to the mechanical team. So how do you show that you're actually good at it? What the Building Safety Act says is about skill, knowledge, experience and behaviour. And what we're going to try and show you in this example of smoke pressurisation is how you combine all of that to give people confidence in the people you go to understand what they are designing for you and what is actually installed. So I'm going to pass you over to Radek now. The reason for that, there's a thing about competency, so I need to go to Radek because he's much better at doing this than I am.
Thanks, David. Okay, so pressurization systems are the best solution to provide fire safety for evacuees and best conditions for firefighters, especially in tall buildings. This system is widely used in around the world, yes, in Europe, North America, in the Middle East, Singapore, Australia, but it is not the first choice here in the UK, and there is excellent reason for that. It is here where those systems' efficiency has been challenged, has been questioned, and a lot of challenges for those systems were pointed. And I fully agree that without identifying and addressing those challenges, we cannot make properly working system, and it is not only about pressurization, it is about any system. And this is why I'm worried when I meet the approach that oh, you're doing pressurization, but what to do there? It's just a fun. It's just a fun. And in reality, it's not just a fun if you want to do it properly. It is a complex, holistic system that has to address all of those issues. And 15 years ago in Poland, we were in exactly the same place with those challenges. But here in the UK, you switched to other solutions. We kept pressurization and we worked to develop them to answer those issues. And I could talk hours about our self-adapting pressurization unit, about testing kits of devices in independent laboratories according to 12.1.1 part 6, about self-testing, automatic self-testing every 24 hours, about our adaptive algorithm that allows us to go from 50,000 cubic meters per hour to 200 in 3 seconds, and then in 3 seconds from 200 to 50,000, and this was proven also in independent laboratory, and without any risk of oscillation, or about our design support. But we don't have time for this. If you would like me to do, you can invite us for CPD on pressurization. But here today, as we are at the Tall Buildings Conference, I wanted to focus on the most challenging issue for tall buildings, which is the stack effect.